Hi everyone, thanks for coming this afternoon. I know it's been a long day and we were running a bit behind, so I will try not to take up too much of your time. But while we do have this time together, I wanted to walk you through some steps that you can take to erase unconscious bias from your AI data sets, the data sets that you use to train machine learning algorithms. And more specifically, I'll give you 6 steps that you can take on product and development teams to reduce bias within the data sets you use throughout the product lifecycle. So my name is Lauren Maffeo, and I'm an associate principal analyst at GetApp, which is a company owned by Gartner. GetApp is TripAdvisor for B2B software. So the idea is that if you're a small and mid-sized business owner and you need any type of software for your business, whether it's a CRM or sales software, the idea is that you would go to getapp.com, read LinkedIn verified reviews of different SaaS products, you would filter for the features you need, and ultimately choose the tool that's the best fit for your business. At GetApp, I cover cloud business intelligence software, which transcends almost all industries. And I also write and research about the ways that small and mid-sized business owners can integrate technologies like AI and blockchain into their businesses. So this is a little more info about me. There's a link to my GitHub up there, along with links to my Twitter account and an interview I did with the Association for Computing Machinery on this topic, in case you want to learn more about it. I am also a community moderator for opensource.com, so I'll take this time to share that if you are working on any open source project that you would like to write about, part of my job is to recruit new writers. So if you're interested in writing for opensource.com, please come talk to me afterwards, and I'd be happy to work with you on that. This is a picture of me at the starting line of my first marathon in 2016. I didn't look that happy at the end of it. That was me at the start line. And to start the presentation, I want to take us back to 2015. Who heard about a website or knows of a website called howOld.net? Some of you. So it was a website that was set up to use facial recognition software to guess your age. And so it's still online. And last August, I wanted to have some fun with it. So I uploaded a photo of myself to the site that was taken earlier that month. And I was flattered to see that howOld.net apparently thought that I was 24 years old, because that's a little bit younger than I actually am. I was less flattered when I uploaded a photo taken of me just 3 months prior, and the same website thought that I was 38 years old. So I aged 14 years going forward 3 months. And howOld.net made the news when it came out as an example of how facial recognition software meant well, but was still pretty immature and had a long way to go towards mass adoption because it was incorrect. The problem is that machine learning gaffes like this aren't always funny. They can have serious consequences for the end users of products that are built on data sets that rely on machine learning algorithms. And in its extreme cases, machine bias can actually hurt end users. So the biggest example out there right now is a product called Compass. Compass is an ML algorithm that predicts defendants' likelihoods to recommit crimes. And research from ProPublica, which is a nonprofit journalism outlet, found that it has been proven to make biased predictions based on race. The algorithm has predicted, with a sample size of more than 7,000, that it has been 2 times more likely to predict Black defendants as high risk for recommitting crimes. It has also been 2 times more likely to predict white defendants are low risk for recommitting crimes. But there's a big problem with both of these numbers. They're incorrect. And this isn't a what-if scenario. Compass is a product that has been used by judges in over 12 US states to confirm prison sentences, including the lengths of those sentences and whether defendants are released on parole while they're awaiting trial. And based partially on Compass's recommendations, a judge in Wisconsin denied probation to a man named Eric Loomis. Instead, the judge gave Loomis a 6-year prison sentence for driving a car that had been used in a recent shooting. And Loomis tried to take this case to the Supreme Court, But when he took it to the Supreme Court, the justices refused to give it a hearing. And this was a very dangerous legal precedent to set because it signaled that most Supreme Court justices condoned the algorithm's choices without knowing how it reached in conclusions that were often incorrect. And this is dangerous, especially because confusion about how AI works shows no signs of slowing down, and it reinforces this concept that algorithms make objective decisions when that is not true for a variety of reasons that I'll talk to you about today. The question about Compass is, did someone do this on purpose? They probably didn't. We can safely assume that this was not intentional. It's more likely that this was an unconscious mistake. The Compass algorithm probably didn't get enough training data to recognize diverse kinds of facial variables, including skin tone. It's also possible that the algorithm drew from historical data about rates of arrests between people who are Black versus people who are white and incorrectly correlated skin tone with recidivism. We don't know for sure because the Compass algorithm is what's known as a black box. I'll expand on that later in the talk. And a big risk with algorithms that are black boxed is that we don't know how they make decisions. Even their creators don't know how they make decisions. But we can infer, based on Compass's flawed results, that machines have their own biases just like people because of bias in the data sets. And that's what machine bias is. It's programming that assumes the prejudice of its creators or its data. So this is a problem, and it's a big one, but we'll start by solving it today by answering 4 key questions. I'll go into more detail about what machine bias is. I'll expand on why it's dangerous for end users. We'll talk about the root cause of machine bias. And finally, I'll give you the 6 steps you can start taking with your product and dev teams to start eliminating bias from your product development life cycles. So let's start with the first question. What's machine bias? We already talked about this a little bit, but it's worth unpacking that a bit more because we all have bias whether we know it or not, and I'm no less biased than you are just because I'm up here giving this presentation. Some people actually say that bias is what makes us human, and they point to our bias as the reason why algorithms should make big decisions. Machines don't get tired, cranky, or irrational like we do, and so the thought process says that outsourcing big decisions to them will yield more objective results. But as we know now, that's not the case. Machines and the data sets that they're trained on have bias just like the rest of us. And that bias manifests itself in 2 ways. The first is through direct bias. That is when models make predictions based on what's called a sensitive or prohibited attribute. So these are really obvious things like race, religion, gender, and sexual orientation. But believe it or not, this actually isn't the biggest risk in machine bias. Indirect bias is a bigger threat because it's harder to detect. This is a byproduct of non-sensitive attributes that correlate with sensitive attributes. And this is an example of where Compass went wrong because we can infer that the algorithm's predictions correlated with race, even though the creators say that race wasn't a variable included in the data set. In the case of indirect bias, the outcomes for one group are compared with that of another, and if the difference exceeds an agreed upon threshold, that model is considered unacceptably biased. So if the difference in incarceration rates varied more than some percentage between prisoners of different ethnicities, that's how you can start to infer that the algorithm is biased. And machine bias is also dependent on 2 big factors. The first is the priorities that were set out at the start by the algorithm's designers. And the second is with which methods of fairness were accounted for at the start, because fairness is a subjective concept. And so if you haven't defined at the outset what that means in the context of your training data and your model, that's where you're going to run into trouble. And when we talk about measures of fairness, that defines how to treat all participants in a system with equal respect. And there's a wide range of possible measures here that often have negative correlations. That's because as fairness increases by one measure, it often decreases by another. And like on any product team, this is going to lead to competing trade-offs and priorities. So let's go back to the criminal justice example. In this case, the algorithm's designers have to decide at the outset which trade-offs they're going to make and which end results are the most fair. So at an extreme level, they have to decide, should 10 innocent people go to jail to make sure that one guilty person isn't released? Or should 10 guilty people be released to keep one innocent person out of jail? This is an exaggerated example, but regardless of which choice designers make, their product's users will feel the impact of that decision. And again, it goes back to the concept of fairness as defined at the start of using the data. If you haven't done that, that's where you run into dilemmas like this. And that leads us to our second question. Why is machine bias dangerous? There are several answers. The first is that machine bias reinforces human bias, and that does that in a few ways. At a basic level, machines are like toddlers, and they only learn from what they know and the data they're given. So if machines are fed data that reflects its creator's unconscious bias, the machines themselves will reflect that bias in a variety of ways, even if this isn't intentional. And this isn't a new problem. The volume of data we're dealing with today is more enormous than ever before, and so the problem has been exacerbated, but this goes back decades. St. George's Medical School in London used an algorithm in the 80s to take a first look at applicants to its medical school. It analyzed admissions records to find characteristics of successful candidates, and then it was adjusted until its decisions matched the characteristics that the admissions team wanted to see, because the admissions team thought if they could just automate the process of looking through all of those resumes, they could save themselves a lot of time. And in theory, that was true, but 4 years later, 2 doctors realized that the algorithm was biased. The algorithm was rejecting female and non-European sounding names for interviews, even though those candidates met all of the other qualifications to interview for places at med school. And so as a result of being screened out, up to 60 applicants each year were being denied interviews. Again, they were qualified otherwise to interview for positions, but they were being screened out because of incorrect associations. The second problem with machine bias is that it doesn't account for context. They only learn from the data they're trained on, and so algorithms don't understand nuances like regulation changes. And they also don't inherently know if the data in them is biased or homogeneous. And this increases the risk that they'll reinforce early biases in a number of ways. From a political perspective, one case story of this is the practice of redlining in Portland. From 1859 to 1990, people of color were banned from buying property in certain neighborhoods in Portland, Oregon. And even though that's illegal now and has been for almost 30 years, we have more than a century's worth of real estate data that is based on a practice that's now illegal. And so if you're training a predictive model on that data set, you run the risk of reinforcing bias that is now illegal. And that bias can impact who gets approved to buy homes and where those homes are located. The third reason machine bias is dangerous is the most extreme, and in extreme cases, it can put users' lives at risk. Users of AI-powered systems put our trust into their designers and engineers, and if those teams are too homogeneous, they won't build for diverse user needs. One example of this on a more basic level is crash test dummies. In the 60s, crash test dummies were modeled after the average male's height, weight, build, etc. And as a result of that, today, female drivers are 47% more likely to be injured in a car crash, and female crash test dummies weren't brought to market until 2011. Now think about a self-driving car and the era we're in where that technology might reach mass adoption within the next decade or two. Consider what would happen if the speech recognition software in that autonomous car can't recognize different types of voices because it was trained on a narrow set of speech patterns, and it can't recognize different accents and inflections. The results could be deadly in extreme cases. And Dr. Carol Riley, who is an entrepreneur in AI, really hit this home in an op-ed she wrote for TechCrunch about bias in AI. She said, if these systems don't recognize people of every race as human, there will be serious safety implications because of how these products are being used. You can't solve a problem, though, if you don't know what the root cause of it is. And so that brings us to the question of, what is the root cause of machine bias? A big cause of the problem we're seeing today is black box algorithms, because it's hard for us to know if an algorithm's results are truly fair. And this is hard even for the algorithm's creators sometimes, because machines often behave differently in deployment than they did in production. And the result is that in extreme cases, none of us can see inside an algorithm to learn how it makes decisions. When we don't know how algorithms make decisions, we ultimately can't fully trust them, and we can't trust their results. And in the near future, companies will have no choice really but to explain their algorithms' results. And they'll have to be accountable to what Cliff Quang calls the black box problem. It's an inability to discern exactly what machines are doing when they're teaching themselves novel skills, because the whole concept around reinforcement learning is that you're automating the learning process for the algorithm rather than having to input yourself. And sometimes the creators don't have enough insight into what goes wrong there, but that's going to change. We're already seeing legislation in Europe that would fine large tech companies for not revealing how their algorithms work. And that might sound extreme, but research shows that's actually what users want. Research from the University of Chicago and the University of Pennsylvania showed that users have more trust in modifiable algorithms than in those built by experts. They actually trust algorithms more when they can see how they work, even if the algorithm's results are wrong. And I think this makes a big case in favor of open source, because in theory, if you can see how an algorithm made decisions, even if that decision's incorrect, you can still take steps to help solve it by getting into the data. And so that really supports the crucial role that transparency plays in public trust of tech, because again, people prefer AI algorithms when they can clearly see how they made decisions, even if the end results are incorrect. So the problem really does relate to the black box concept. But it would be disingenuous of me if I stood up here saying that black box algorithms are the problem without acknowledging some of the limitations there are to making everything open source. When I was at Open Source Summit North America in Vancouver last August, I led a BOF session with a bunch of developers about this topic, and I talked to them about some of the limitations they come up against with black box algorithms and some of the challenges they would have in making their creations more transparent. And there are a couple. The first is the most obvious. Black box algorithms are considered proprietary if they're part of a large corporation, and so they're thus often not revealed at the risk of exposing trade secrets or competitor advantages. They're also based on endless neurons, and each neuron has its own bias. And so at the end of the day, it becomes a question of whether you can ever fully erase bias at all, because it's so complex and there are so many factors that correlate with each other. And the third is that they're at risk of being manipulated by bad actors. During this BOF session, I talked to a program manager at Twitter, and he said that his team is constantly on the defense against people who want to figure out how their algorithms work so that they can manipulate them for their own benefit. So to his point, he was an open source advocate, but he did say that's a practical concern that you just have to acknowledge. But for transparency's sake and all of the reasons discussed, I still make a case that algorithms like this and data sets that they're trained on should be open where possible. And this is where open source frameworks like Drupal, for example, have a competitive advantage. They have large amounts of tagged structured data, and those are big advantages when you're trying to train an algorithm. Frank Carey gave a really good presentation on this topic at DrupalCon Baltimore 2 years ago, and he explained why Drupal data is pretty ideal to train deep learning and neural networks. And again, a lot of it comes back to the concept of tagged structured data, which is an asset when you're training these algorithms. And these networks, when you use them, can make a big range of improvements to your site. If it's on a Drupal or WordPress site, and they range from generating alt tags to image captioning. So there's a lot that you can do with it if you are able to take use of it. And luckily, we're seeing more open source toolkits coming out these days to do things like text classification and reinforcement learning. So one example is a toolkit called Lime. It's an open source Python toolkit that's based out of the University of Washington, and it doesn't try to dissect every single factor that influences an algorithm's decisions. Instead, it treats every model as a unique black box. Lime uses a pick step method to select a representative set of predictions or conclusions that it wants to explain, and then it approximates the model close to those predictions. Finally, it manipulates the inputs to the model and measures how predictions change. So here's an example of a Lime classifier from text classification. They took two classes, atheism and Christian, that are tougher to distinguish since they share so many words in common. Lime's researchers trained a forest with 500 trees and got a test accuracy of 92.4%. So if accuracy was your core measure of trust here, you would be able to confidently trust this algorithm. And ultimately, responsibility for algorithmic choices doesn't start with regulators or governments. It starts with all of you. It starts with strong data, development, and product teams that are collaborating to make sure that the parameters are as fair as they can be for the end users. And the good news is that while bias in data sets used to train ML algorithms is inevitable, it's not unmanageable. There are several steps you can start taking now to boost the health of the data sets you use to train ML. The first is really essential. It's to document your priorities up front. And this requires you to answer two key questions in the product specification phase. You want to answer which methods of fairness you'll use and how your team is going to prioritize them. So here, sensitive attributes should be identified and declared out of bounds unless you make an explicit justification for including them. You'll also want to include a minimum threshold of acceptance and acceptance functioning before you deploy the product. And this is helpful criteria both for internal product and dev teams, but also if you're in a position to choose an external vendor who says they use AI. As an analyst, there are a lot of cloud software products out there claiming to use AI techniques. And if you're going to be purchasing that product, as a consumer, you should be asking questions about how they train their models, because if they can't answer these basic questions, which they should have done in the product spec, you probably should think twice about adapting that product in your organization. Again, it comes back to the aspect of accountability, both on tech teams, but also when you're bringing a data set into your organization, because then if it produces biased results for your customers, you could get into a bit of trouble. So this is really something that you want to focus on if you're in a position to train an ML algorithm, but also if you're going to adopt AI-powered software for your business. The second step is to train your data under fairness constraints. And this is tough because when you try to control or eliminate direct or indirect bias, you're going to find yourself in a catch-22 at first. Because if you train exclusively on non-sensitive attributes, you'll eliminate direct discrimination, but you'll introduce or reinforce indirect bias. But if you train each separate classifier for each sensitive feature, you'll reintroduce direct discrimination. Another challenge is that detection can only occur after you've trained the model, and when this occurs, your only recourse is to scrap it and retrain it from scratch. So to avoid that, don't just measure average acceptance and rejection across sensitive groups. Instead, you want to use limits to determine what is or isn't included in your model. And this expresses discrimination tests as restrictions and limitations on the learning process, which again allows you to train the data under fairness constraints. The third step is also crucial. I would say it's as important as step one. You want to appoint someone to own the process of monitoring your data sets throughout the product lifecycle, not just when the product is in production. That's because developers building training sets based on data, they do this with data they hope their model will encounter in deployment. But many of them don't monitor the data that their creations receive from the real world, which can lead to a host of problems. So bias should be reduced as much as possible while maintaining an acceptable level of accuracy as defined in the product spec. And as mentioned, it's not uncommon for the algorithm to update itself without the model itself being revalidated. That's another reason why you want to have someone making sure that the data it's receiving is acceptable rather than fully automating it. Because if unacceptable biases or behaviors are detected, the model should be rolled back to an earlier state prior to the first time the person saw bias. So again, you want to monitor someone to consistently monitor the source, history, and context of the data. The fourth step is to tag your training data. We mentioned earlier that tagged data is an advantage when you're training a data set. And tagging refers to which classes are present in an image and their locations. But doing this at scale and with accuracy is a huge challenge, both from a time perspective and from the perspective of cost. Because the cost of tagging a data set is directly proportional to the amount of data, and the amount of data is an advantage when you're training an algorithm. The good news is that more products are coming to market so that they can decrease the time and cost of tagging. One of these products is a tool called Brain Builder. It's a SaaS product that's based in Boston, and they use open source frameworks like TensorFlow to help users manage and annotate their own training data. Brain Builder also aims to bring diverse class examples to data sets, and this is another key step in the data training. It's the next step. You want to use diverse class examples when you're using training data. That's because training data needs positive and negative examples of classes. So if you want specific classes of objects, you need negative examples as well, because this more closely mimics the data that your algorithm will encounter once it's out of production into deployment. So one example of this is to consider the concept of homes within a data set. If an algorithm only contains images of homes in North America, it won't know to recognize homes in Japan, Morocco, or any other international locations, so its concept of a home is thus limited really to North American users. Luckily, 2018 in particular saw a strong increase in the number of open source AI data sets. And so Synced has a helpful roundup of 10 data sets for different use cases, from multi-label images to semantic parsing, that were all open source last year. And if you're looking for public data sets by industry, GitHub also has a pretty comprehensive list. If you are interested in getting the direct URLs to these posts, feel free to come talk to me afterwards, and I can take your email address and email the deck to you. Because again, if you're looking for data sets to deploy in your organization, these are some good ones. And there are more coming out every day, so make sure that you're keeping on top of what's out there so that you can start building larger data sets, since size is an advantage here. And the final piece of advice I have is to focus on the subject, not the context, when you're looking at images in a data set. So let's start by looking at the data set on the left. This is an example of a biased data set. That's because wolves were tagged standing in snow, but this model wasn't shown images of dogs. So when dogs were eventually introduced, the model started tagging them as wolves because both animals were standing in snow. Classification errors like this mean that the model being trained was either incomplete or inaccurate. Whereas on the right, you have a training set from Brain Builder that is focused on the subject, which is dogs. And this really reinforces why it's so important to have someone monitoring the data sets you use and to not automate the process, because that helps you figure out where the bias creeped in so that you can roll back before you're too advanced through the life cycle. I just threw a lot of information at you, but if you leave the room only remembering one thing, I want it to be this. Ethical debt is the same thing as technical debt. That's because bias leads to poor data, which leads to a poorly trained neural network, which leads to a bad user experience that in some extreme cases can be deadly. And when that bias is found, your only recourse is to scrap it and retrain it from scratch, which is a ton of work for your team. And I want to backtrack a bit because I said earlier the title of this talk is Erase Unconscious Bias from Your AI Datasets. And you can't really erase bias from your data sets. It's a constant threat. It's always at risk of creeping in. You're always going to have trade-offs between competing priorities and fairness versus accuracy. But there are steps that you can take, like the ones I mentioned, that can decrease the risk of bias, again, throughout the life cycle, both in production and when you bring your product out into deployment. So as a final step, these are some resources that would be great if you're interested in learning more about this topic. The first article in particular just came out earlier this week, and it's less an article about AI at Microsoft, and it's really more about how to assess the health of the open source data sets that you use. So we talked about volume of data being a big advantage here to train your models, but the quality of the data is also huge, and a lot of large data sets have their own biases. So then the question is, how do you figure out where the bias crept in and how you should erase it when you're using it to train your model? And this article gives a really strong overview of that. If you want to try out the Brain Builder products that I mentioned, you can sign up for a free trial using your own data via this link. And if you want to learn more about how ProPublica analyzed the Compass algorithm, if you want to see more information about Lime, or learn about the algorithm aversion concept, all of these links are here. So again, if you want direct URLs to them, feel free to come talk to me afterwards, and I will email you the deck. Thank you.